Okay. Here we go to page 711. Only we were at 711. Third page or something. All right, yesterday we talked about doing the butterfly method. I circled diagonally the 3 and the x minus 7, and then I write the equal sign. Circle diagonally the 2 and the 5x. And then distribute. And then we have 3x minus 21 equals 10x. And then yesterday, the problems got really complicated if you had x squared. But we don't have x squared. So this is just moving, collect the x's together. So I'm going to subtract 3x, move it over to the other side. Negative 21 equals 7x. Divide by 7. We don't make zeros if we don't have x squared. We get negative 3. Anybody get it right? So many. Very good. Very good. Okay, next one then. Butterfly this. Negative 4 times x minus 3. Write your equal sign. Butterfly this. 5 times x plus 3. Very similar. Minus 3 and plus 3. Distribution. Negative 4x plus 12. Distribution. 5x plus 15. Again, no x squared here. We don't have to factor. This is good. Add the 4x over to the other side. That's 12 equals 9x plus 15. I always try to collect the x's together first. It's a good system. Subtract 15, and then I'm at negative 3. And then this is where some people will they always think the smaller number moves. But remember, we're trying to get that x alone, so I'm going to divide by 9. It's not always the smaller number that moves. Negative 3 over 9 equals x, so that's negative 1/3. That one was a little more difficult. Did anybody get that one right? Negative 1/3. Okay. There we go. Any questions on bell work? All right, let's check yesterday's assignment, and then we'll get into today's problems, which is a little bit trickier, but also really, really great. Here's the answers. It's a bit blurry. There. I'm going to walk around and check page 717. Yeah, once you start with number 5, you should end up. Okay, you ready to keep going. Oh, yeah. And that's explanation. And then you gotta make this equal 0, so you subtract x squared and add 1x, and then you subtract it. Mm-hmm. If you're still working on it while I'm walking around and giving you credit. If you were taking the quiz yesterday and you need another day, like makeup work, you got it. Two people who were taking the quiz, that's what happened. Yeah, I did it. That looks good. You were taking that. Well, starting with number 1, we're going back there. Anybody have any questions? 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 Oh man. Okay. Oh.
Oh, so you just put a one in it, okay.
Yeah.
And you wrote it.
Yep. Still did butterfly method with the 1.
Okay.
These are like the real. These 2 problems are the ones you should probably spend the most time on. They're like the real application problems of like getting averages, future averages. Just plugging and chugging. What this means for number 10 is that you have to get, is that he wants his batting average to be .360. I wonder what his current batting average is. 12 out of 60. Is that how it works?
Yeah, I think it's 200.
Is that good? Or? Okay, 12 out of 60 is what he currently hits. 0.2 or 200. And he wants 360. So they're saying like if he just hits every ball for the rest of the season, when will he get up to his goal? And this means so far 12 out of 60. He'll have to hit the next 15 correctly to move his average up. So that would make it 27 out of 75 because you're plugging in 15 here and here. So let's just divide that real quick. Is this 0.360? That's what we're claiming. I did my math right. And it is. And it is. So this is how this guy figures it out. So maybe people who gamble set that number, and then, you know, if you're not supposed to go over it, you just start missing after that, so you can win the big money. I don't know. I was thinking about gambling when it comes to math. I don't know why I don't gamble. I don't even buy lottery tickets. I'm not promoting it. I can't even buy a lottery ticket. I don't spend money, honestly. Okay. So let's get into some other problems where instead of it just being the butterfly method, it's more complicated. It's 2 fractions and an equal sign and then another fraction. 3 fractions instead of just 2. This first quote here is directly from page 712 of your book. I kind of just wanted to emphasize this is what we're doing. There's another process to doing these problems, but it will become more complicated if you don't use this process. This is exactly what the book shows, and this is how I've always known to do it as well. So when a rational equation is not a proportion, that means it's not just a fraction equal fraction. And when it's a little more complicated, you solve it by multiplying each side of the equation by the least common denominator. So we're going to use the LCD to clear fractions. And it's kind of magical the way it turns out. Here's the 3 steps we're going to use. First, well, you figure out the LCD and then you multiply both sides. The only way this happens is if you have an equal sign. You can multiply both sides by an LCD. Step 2 is you don't actually multiply. You set it up, but you don't actually multiply it. Instead, you cancel out denominators. You reduce diagonally. This will clear every fraction out of your problem. And then you solve what's left. Hopefully, you're left with not x squared, because as soon as you have x squared left over, you have to factor. But you just solve whatever you're left with. Why is the assignment gone? I'll write it again. So I'm just going to jump right into problems. I'm going to do, it's 17 to 22, but I'm going to do evens as classwork and odd on your own. So we're going to get through 3 problems, 18, 20, and 22. And then you'll have the odds to work on your own. So I'm going to wait, let you guys read this and write it down. And when you're ready, I'm going to start with number 18. look. Okay. My recommendation is, while this looks so small and innocent, is that you actually take quite a bit of space on your notebook paper and spread it out. I kind of try to spread it around the whole width of the notebook paper. I'm going to write it really big up here, actually. So I got 2 over 3x, a plus sign, 1 over 6, an equal sign, 4 over 3x. So I start by spreading the problem out, because my first step is to multiply everything by the LCD. So what is the least common denominator? We haven't had to talk about this since before break. So many great guesses. 12 is a really high number that they both go into. Because I'm looking, is there something funny? So when I look at 6 and 3, I want 3 goes into 6 and 6 goes into 6. So I'll pick 6. And then there's also an x present, so I'll pick 6x. Okay? 12x would work fine. If you pick too high a number, it's okay. If you pick too low a number, that's when you won't be able to finish. But 6x works. So multiply every part by 6x. So I picked the 6x, and now I set it up. I'm going to multiply all 3. Because we have an equal sign, if I just do it to both sides of the equation, you're good to go. So I'm going to do 6x times this one. I'm going to do 6x times this one. And I'm going to do 6x times this one. So actually, I'm going to look at each one of these parts as its own little multiplication problem. I'm going to deal with each part separately. So really what I have here is 3 little multiplication problems, and you guys already know how to multiply, so that's good. You know, I don't like to multiply unless they're both fractions, so I'm just going to do it like this. All right, so our next step is to reduce diagonally. It said, in the step, it said, don't actually multiply. It said reduce. So we're not actually going to multiply this. We're going to reduce it. Well, I have x over x, so those are canceling. X over x is just 1. It cancels. And then I have 6 over 3, which also can be reduced. 6 divided by 3 is 2, right? So, well, 3 goes into 3 once, 3 goes into 6 twice. So that's the reducing. Because 6 divided by 3 is 2. Okay? So what am I left with? 2 times 2. All I have is a 4. If it's difficult for you to reduce diagonally, you could just, no, you better just reduce diagonally. You gotta just get to it. You know, 6 times 2 is 12, and 12 divided by 3 is 4. So, anyway. All right, next one. Again, we're going to reduce diagonally. This is really over 1. So what can I reduce this time? I can reduce the 6's. The 6's cross out, and all that's left is x times 1. Or 1x, or just x. Everybody okay with that one? Bring my equal sign down. Now what reduces? Put this over 1 again. Yeah, the x's cancel. And 6 divided by 3 is 2. So now I have 2 times 4, so that's left there. That's 8. Just like that. There's no more fractions. It's crazy. Like, look how simple it is. They can. Let's cross them out too. You're right. Those do cancel. So it's just X up there. It's even better. I'm gonna do that the whole rest of the day. Okay, so now I solve whatever's left. Now it could be more complicated than this. This one's short and sweet. Subtract 4 from both sides, and we got our answer, x equals 4. It's best if you spread it out and just make it real clear and neat. You rush through it, it's easy to make mistakes. All right, number 20. You want to start 20 on your own? My plan was to do all the evens and then you're going to do odds on your own. But I can pause for a moment. A little pause. One thing I do want to start out just by saying, because this LCD has always been tricky, a lot of times it's easy to think that since there's an x here, that our LCD can just be x minus 3, but when x is by itself, it has to be by itself in the LCD. So it's x parentheses x minus 3. You have to include both of them. Don't just do x minus 3. If this little guy is by itself, it's like if there was a 5 there, you'd have to have a 5 out front. There's an x there, there has to be an x out front. Okay. Now, I'll wait and let you set it up. Try to set it up if you want. Well, have you looked at the answer and you don't have it right? Is that why? Yeah, it is really long. So your LCD is x plus 4x minus 1. And then so you ended up with 2x plus 2 times x plus 4. And then you ended up with 6x squared minus 6x. So you got a 4x squared problem in there? Yep, those are the right answers.
I ended up with like 8x squared minus 4x minus 140.
You could divide everything by 4. Yeah, that sounds good. Okay, I'm going to spread the problem out. I got 2 over x minus 3 plus sign 1 over x equals sign x minus 1 x minus 3. Now I'm going to multiply everything by the LCD. Just realized I did the other check. This is only possible because of the equal sign. We could not have done any of this last week before break. This is only when there's an equal sign that you're allowed to do this. All right, put this over 1. And then what you have here is actually 3 little multiplication problems. So we're going to look at this one, separate from this one, separate from this one. It's 3 multiplication problems that you've set up. Reduce, 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 reduce before you multiply. So in our first one, I reduce anything that's the same up and down and diagonal. The x minus 3 is reduced. And all we have left is 2 times x. That's great. Really got rid of a big part of the problem right there. Reduce. So in this middle bit, what can I cross out? Well, there's x's diagonal. So I'll cross out the x's, and I'm left with, well, cross out the 1. And I'm left with x minus 3. Equal sign. Reduce. X minus 3 cross out. And now, unfortunately, I have x times x minus 1. What's unfortunate about that is that means we have a quadratic. So that's the part that's new to you. All of that. This from here, you're supposed to be able to solve. Who's got a question on what we've done so far, the reducing? You should feel really good at this point because you no longer have fractions. You have clear fractions. Everything's just a one-liner. It's kind of a sigh of relief. Should I keep going? You want to finish it? You finish it, Ethan? Okay. I'll combine my terms. 2x and x will be 3x minus 3. I'll distribute this. X squared minus x. Because it's x squared, we'll have to set one of these equal to 0. We'll want a 0 here. So I'm going to move these to the other side because I want a 0 with all quadratics. So I'm going to subtract the 3x over, the line in there, add the 3 over. 0 equals x squared minus 4x plus 3. And then you have to factor it. What multiplies to 3 times to negative 4? Negative 3 times 1. Negative 1 is a positive 3. Got my 0 here. Make both these little guys equal 0. And then you have 2 answers, but I think one of them is going to be a problem. So I got x equals 3 and x equals 1. But I got a serious issue with x equals 3. I wanted to mention this yesterday, but it just didn't come up. X equals 3 is going to get rejected. This one's rejected. We're not accepting it. It's called extraneous. It's a no-go. It's actually an undefined value. So I'm only going to box 1. The problem with 3 is when I look at the original equation, if I put a 3 in the start, if I put a 3 in here, 3 minus 3 is 0. It comes out undefined. So, because I practiced this so much, this has been on my mind on all of our questions we've done the last 2 days. Every time mentally I've gone back and checked. This is the first one there's been an issue with. So this is my first chance to bring it up to you. You have to go back and look, will this make any zeros and denominators? And if it does, it gets rejected. So, one works. You can do a quick plug in here and see how 1 makes this equation show. Because this would be 2 over negative 2 is negative 1 plus 1. And then 1 minus 1 is 0. 0 up top is okay. So negative 1 plus 1 is see how it works. That's that. Who's got questions? All right, I got one more. 22. And then you'll have 3 odds to practice on your own. All right, so when I see 22, the first thing I'm dying to do is to go ahead and put that 3 over 1. Like, let's just put everything in fraction form. Just line it all up. And so the LCD this time is x minus 4. So I'm going to pause and let you guys spread it out, set it up, and try reducing. And then I'll jump in a minute. I think I'm going to make it work. And then that's the A times C method. I was just talking to a different student. Have you done the A times C method? That doesn't sound familiar to you. This might be how you just do your parentheses, and you know you need 2x squared, right? So now you have a 2x here and an x here. And then you know you need 40. So you just guess and check what numbers here will create a 40.
I do it like somewhere like that. I know that like you take two numbers on, like you take 2 factors out of the 2 and 1, and then you take 2 factors out of 40, right? And you cross multiply it with like ironically that's like here.
Like if I pick 4 and 10, where do I put the 4 and the 10?
Right here, actually, on my page.
Sounds awesome.
Right.
You put the 5 and 8 here, and then 2 and 1.
And then cross multiply that, and then you cross multiply the values.
Right.
And then you get 2x plus 5. Let's say you check 2x squared times 16x plus 5 times 40.
So what if the 2 and the 1 and the 1 cancel? You just keep flipping them until you find it.
If it was like a 4 or something, you could do 2, 4, and 1.
I've been 22 yet? Why didn't you do 22? Oh, and then you're just going to take a picture of the unit? Okay, the LCD is x minus 4 and x. No, x plus 4 and x minus 1. Okie dokie. Alright, so I'm going to spread this out. It's 10 over x plus 3 over 1 equals x plus 9, x minus 4. I'm going to write my LCD, which is x minus 4, next to every part of this problem. Might as well put that over 1. And then I'm going to look at the first part as its own multiplication problem. the second part as a multiplication problem, and the third part as a multiplication problem. And then I will reduce. The x is reduced. So I have 10 times x minus 4 plus sign. And the second one, none reduces. So this 3 in the front and the x in the front, they can partner up. And this is 3 times x minus 4. The 3 and the x go jammed up together. And then the x minus 4 is crossed out. So this would be x plus 9. And then honestly, that's really the only part that's new to you. From there, you're supposed to distribute, bring everything to one side. Here's all that distribution. Because it's x squared, I want it to set equal to 0. So I guess first I'm going to simplify all this. That's 3x squared minus 2x minus 40 equals x squared plus 9x. This is 2x squared. Move the 9x over as well. Minus 11x minus 40 equals 0. And now you have to do the A times C method. This is where lots of us are forgetting how to do the A times C method. All right, how do we factor when A is not 1? Well, we'll go 2 times negative 40 is negative 80. And we need numbers that will multiply to negative 80 and add to negative 11. So I'm thinking of what, 8 times 10, 20 times 4. It's going to multiply to 80 and add to 11. Five. 16 and 5 work. If 8 times 10 works, divide 10 by 2 and multiply 8 by 2 and you get 16 and 5. 16 and 5 are the numbers. So it'll be a negative 16 and a positive 5. This is what's more difficult about the A times C method. Now I rewrite the problem with the new middle. You put the numbers that you picked in the middle, remember that? And then you factor by grouping. So take a GCF of the first two, take a GCF of the second two, be 2x, x minus 8, 5, x minus 8. Remember your parentheses must match. Bring those together. And we get two answers. X is 8 and x is negative 5 over 2. Yes,